Problem number 18 says, find the particular antiderivative that satisfies the following conditions. The derivative of y with respect to x is the quantity 3x plus 5 over the cube root of x. And we're given the initial condition that when you plug in x equals 1 to the original function, you get 2. Or the output is 2. So the way that I would start this is to acknowledge that this is the same as a derivative. This is the same as f prime of x, or this is the same as y prime. So whichever notation you feel most comfortable using, it's good to recognize that all three of these notations are correct. So if we need to find the particular antiderivative, that implies that we have to take the antiderivative of both sides. So we would take the antiderivative of this side and the antiderivative of this side. Well, so we just have to take the antiderivative of both sides. And when you take the antiderivative of the derivative, you get the original function. I should have probably used the f prime of x dx because that looks more appropriate. And so we're taking the antiderivative of both sides. And when we take the antiderivative of the derivative of a function, we get the original function itself, because these are opposites. The integral is the opposite, or the antiderivative is the opposite of the original function, or the derivative function. And so we would just get f of x in the end, and that's equal to, well, when we take the antiderivative of this side, we can break this down into two cases. So my first step would be, I want to change the denominator. So this is the same as saying times x to the negative 1/3 power. And so now we can actually distribute this negative 1/3 and then differentiate, or anti-differentiate. So this would become the integral of 3 times x to the 3/3 power minus 1/3. So this would become x to the 2/3 power plus 5 times, well, there's no x's, so we just, this exponent just tags along, so it'd be times x to the power of negative 1/3 dx. And then we can separate and integrate, so it would become the integral of 3x to the 2/3 dx plus the integral of 5x to the negative 1/3 dx. Constants can move out. So I'll move the constant out, and then I'll also anti-differentiate. So the rule says we add 1 to the power. So 2/3 plus 1, that's like 2/3 plus 3/3. And then now we can add the numerators, and we get 5/3. So our new power is x to the 5/3. And now we have to divide that. So it's 1 divided by 5 divided by 3. I'm sorry, I don't think you can see my screen that low. I might have to move it down a little bit. So now we would technically have to put 3/5 right there. And then we're going to add 5 times negative 1/3 plus 3/3. That's x to the power of 2/3. And now we have to do the reciprocal of that. So we get 3/2 x to the power of 2/3. Well, I'm going to clean this up a little bit more. This was just a little bit of work. So now I multiply this 3 in and this 5 in. So now I would have 9/5 x to the 5/3 plus 15 halves x to the 2/3. And we also have to add an arbitrary constant because we just created a family of curves. When we take the derivative of this, we'll always get the same antiderivative. So there's a full family of solutions here. And that's why we have to use this condition right here, that when we plug in 1, so this is our f of x or our y. So when we plug in 1 to this function, we get out a 2. So y equals 2 when x equals 1. So I would have 9/5 plus 15 halves plus c. And now I would solve this equation for c, plug in our c value, and we would get the antiderivative. And so we would have, I'm going to combine these fractions first. So I'll keep the 2, and instead I'll do 9 times 2, which is 18, over, I multiply the bottoms, so now I have 10, and then I add that to 5 times 15. That's, I know 5 times 5 is 25, 5 times 1 is 5, and then add the 2, so you get a 7 over 10 plus our c. And now I also have 2 equals 8 plus 5. That's a 13, so 3, carry the 1. 7 plus 1, that's 8, plus another 1, that's a 9, over 10 still, plus our constant. And now I would just have to subtract both sides by 93 over 10. So 2 minus 93 over 10 is equal to c. Well, now I need another common denominator. So I know that 20 over 10 is the same as 2. So I'll use that and then subtract 93 from 20. So this would end up being 90 minus 20 is 70, and the 3 minus the 0. So now we have negative 73 over 10 equals c. So that implies that c is equal to negative 7.3. So our particular solution is 9/5 x to the 5/3 plus 15 halves x to the 2/3 minus 7.3.